Okay, guys, today we'll talk about the experimental setup that you have to do at home. The task is to find the universal gravitational, to find the gravity, I mean the G constant. Uh, what you have to do? First of all, I'd like to suggest it three ways to find it, but you may find your own way. The first way I'd like to share with you is the most simplest one. What you have to do first of all, you have to get a altitude, high altitude that has the altitude of h, and you know that since we have the free fall g, the first formula for the free fall, you know that h equals 1 over 2 gt squared. Now you may measure the altitude first of all. So you have to draw the table also. What to do? You have to make some measurements. Let me write it. That is the number of measurements is n. And to make it more precise, you have to do approximately 10 measurements. Let it be 10 for the free fall. So my 10 measurements doesn't fit here. Don't fit here. So you have to take 10 measurements. Sorry. So on the last one, you will make an average. What you have to calculate. First of all, that will be more precise if you change the altitude. Let me write here deep note. What you have to do, change the altitude h. So first of all, you may draw the object. First of all, let it be a ball, a small ball. Don't do it with the heavy objects. No, let's do it with the ball, but maybe a billiard ball or maybe a smaller ball. But don't do it with also light objects because that there'll be some air drag, so the air drag will stop it. So it will be more precise if you do it with a billiard ball or something smaller than this one, and let it be a metallic one maybe. But don't try to catch it or don't drop it into other uh, people's head. So be careful, please, for this. So change altitude. You may change the flow, of course. If you're living in a flat, you may change the flow. First of all, you drop it from the maybe 8th floor or 7th floor, 6th floor, blah blah blah, 8th floor and 4th floor, blah blah blah. You may change the altitude in this way. What you do, you change it. Let it be not 10 measurements. Let it be 5 measurements. Okay, let it be in this way. Okay, sorry. Now, if you change the altitude, for example, you first of all drop it from the 8th floor, let it be from 7th floor, from 6th floor, from 5th floor, blah blah blah, and then from fourth floor. Of course, you have the different time. How can you measure the time? From this formula, we may obtain the time that will be equal to 2h over, you measure the time, of course, with the stopwatch. You have different times, of course, whether it be T1, T2, T3, T4, and T5. And you write here the average. So that they can be 5 measurements also. Measure the time. And if you measure the time, of course, the gravity that you'll find will be 2h over t squared. So that will be the formula that you use, and you'll have different, of course, G. I hope that it will be close to each other, whether it be G1, G2, G3, and G4 and G5. And finally, when you measure the G, you take the average of this, whether it be G, let me write here, G average you write here. When you calculate it, of course, you may calculate it with the T average if you wish, but I think that it will be obtained from this G. How can you find the G average? What you do, you have to sum all of the G that you obtained, okay, and divide by the number of measurements that you made. For example, if for a specific case there are 5 measurements, G1, G2, G3, G4, and G5, and you divide it by 5 and you get G average. That's the first way to measure the G. The second way to measure G, uh, so let's write here this is G caused by, sorry, it is found by freefall, I think that's the easiest one, but the measurements will not be so precise. So you have to be very careful because the T, you have to measure the T very careful, very precise. Okay. The second way to measure the G, right here it's Archimedes force, Archimedes force, Archimedes principle. What you do? The thing that you do is a bit different. You have to take the container and fill it with the water. So, will be pure water, and you have to know its density. Now, what you do? You drop a metallic ball, maybe. Okay, you have to measure the H here, altitude. Uh, of course, the altitude should be measured from the surface of water to the bottom of this container. And you release this ball. Let it be a metallic one. What we have? First of all, of course, it has got its own mg, its own weight, and of course, it has got the Archimedes force that's applied on it. Okay, F Archimedes that's applied here. So you know that we have to find out the volume of the spherical ball. For what we need the volume of the spherical ball because we have to calculate the Archimedes force that's applied on it. So the net force applied to this object is mg minus force Archimedes. And if you find it, force Archimedes, if you find the F net, you have to know that it will be equal to ma. A is the acceleration, of course. To find the Archimedes force, you have to find the volume that's equals 4/3 of pr cube. You may measure also the diameter of this sphere with the ruler. You have to measure I mean, the widest point here, from this point to here, that will be the diameter, and you find it because of the diameter. What you write here, d over 2, and you take the cube of this. Of course, the measurements should be measured in meters. Now, when you find the volume, you may find the Archimedes force that's equal rho, the density of this water. Let it be rho here, rho g and v, rho gv. So rho gv, mhm, rho gv. You have to measure also the mass of this ball, mass of ball, and F net, of course, will be equal. Uh, that is mg minus rho GV, that is here, by the way, that's the weight here, weight of this object, minus Archimedes force will give you F net. So I'll take the G out of the brakes here. So G F net equals Gm minus rho of water, density of water, times V, volume of the spherical ball, and that will be equal F net, that's equal to G m minus rho of water times V, and that will be equal to ma, where the m is the mass of this ball, ma is acceleration. How can you find the acceleration? Of course, you have to measure the time when it comes to the bottom, hits the bottom here. When you measure the time, what you do, if you have the time, of course, you may find the acceleration. How can you find the acceleration? We know that the h is equal, in our specific case, 1 over 2at squared, because the initial speed here is 0. Uh, Now we can't write here the gravity because it's not equal to gravity, the acceleration. So you may find the acceleration in this way. Acceleration equals 2h over t squared. You make 5 measurements. 1, 2, 3, 4, and 5, and ready to write here the average, the number of measurements, 1, 2, 3, 4, and 5. What you measure, that will be more precise if you change the h, the altitude. You may change the altitude if you wish. I mean the depth. You may throw it from this point, hold it with maybe metallic stick, and then throw it here. You may change the h, so you'll find the different t here. Of course, the different a, and then what you find, of course, you'll find the g here, different g, because from the formula you may obtain it from this formula. You obtain that g equals ma over mass minus rho density of water times v. You'll find, of course, different g here. And of course, finally, right here on the table, g average. So that's the second way that I can suggest you to find the gravity. Uh, and that's way is not also so precise, but it's interesting to find it in this way. Uh, I suggest you to use the metallic ball here, not the wooden one, not the plastic one, because it won't fall down. Okay, it can flow, so that's why use the metallic ball, and that will be. I hope that will be interesting here. No, that's not for the A average. That's the average. Now, another way to find the gravity, the way of simple pendulum, and this measurement is very precise. So that will be easy if you suspend a rope here. Let it be a long one, the L. So you make a declination of the alpha here. So and you suspend an object here. The mass of the object is not important. The important thing is the length of this rope. So as the longer one, as longer rope you use, the calculations will be in experimental setups will be more precise. And the alpha, we take the alpha less than about 20 degrees. Use the alpha length then 20 degrees. and take the length greater than, let it be greater than the 1 meter. Now what to do? You release it, and of course it will make some vibrations. It will go in this way and return back. Okay. So you know that the time needed to one complete revolution is called this period. So if you make n revolutions, where did the n is 10? Let me draw the table here. 1, 2, 3, 4, and 5. Let it be number of revolutions. Let's change first, second, third, fourth, fifth, and average. Let's take the number of revolutions. I mean, one, it goes to a far extent and returns back. That will be one revolution. So you measure the time. You measure the time for 10 complete revolutions. 10 complete revolutions. And you have, of course, different T here, T1, T2, T3, T4, and T5 for 10 revolutions. Now, when you make the revolutions here, of course, you can find the period because you measure the time. To find the period, you use the formula T equals total time over number of revolutions. Of course, that will be always 10, but the time will change. So this time will always change. Now, finally, when you find the period, different periods, you know the formula for the simple pendulum, that is 2 pi in the root of Lg. When I take the square of both sides, I'll have here t squared will be equal to 4 pi squared L over G. So the G can be found by formula, that is 4 pi squared L over T squared. So you have also different gravities, and you write here the different G. So you may take the G average then, finally. So that's the third way to find out the gravity. So how you should write the experiment. First of all, you have to write the name of experiment. Name. Of course, everything should be in English. Name of experiment. Experiment. Let it be to find gravity. And you have to write the experimental setup. Setup. These are things that you use in your measurements. So it depends on the way that you choose. I mean, if you choose the way of simple pendulum, you have to write that will be a rope here. Sorry, I wrote a rope and a time watch. Time watch. Let it be a ruler. I hope that's enough. And then you have to write the theory. Write the theory on and the procedure, what you do. Describe the procedure that you do. Procedure. Finally, write down the formula. Of course, you have to write the formula in this here. You have to write the long theory, procedure, and then you have to write the analysis for this, analysis and conclusion for the thing that you've done. Of course, there should be a table, calculations. So this analysis and conclusion should be the last one here. Finally, what you do, you find the gravity by the way that you have chosen. I don't know which way you will choose, but you find the gravity, and you know that when you find the gravity, let it be a g prime. When you find the gravity from this way, you have to find the altitude of your hometown. How you find it? So we know that the g prime equals g capital, mass of Earth, over radius of Earth plus the altitude, or let it be a square here, square. So you have to find the h here. The altitude, finally, you have to find the altitude of your hometown. Hometown. So you may find that when you use what kind of g would you use here? You will use the g average that you find in your table, g average, and from this formula, I want you to find finally the altitude. Write the answer as altitude altitude of my hometown, my hometown, and or write the place. If it will be a Gluboko, please write a Gluboko is about blah blah blah. Write the answer. So you have to bring this experiment, calculations, and all of the stuff when you come here. I will accept it on Tuesday, Tuesday evening. So till 9 o'clock. So from Milan's A grade, A grade. Responsible for this is Dimas. You collect the exercise book from Milan's B grade. Of course, Darren will be responsible. So collect all of the exercise book and give it to me till 9 p.m. on Tuesday. Thank you very much. Let's go today. I hope that you enjoy this experiment. You may find also your own way. If it will be a precise, let me write here. You may find. No, wait a minute. You may find your own way. So if the G will be precise, so if it will be logical, of course I'll give you extra points for your own way. That will be extra 10 points. I'll add to your experimental setup to maybe to the average of the quarter. I'll add 10 points also to your own way. Let it be not 10 points, let it be 20 points. Now you may find your own way and make the G precise measurements. What does it mean? It means that if you get the G, for example, we know that the G should be close to 9.8 or 10 maybe. So if you make your own way, but your G appears to be, let it be G prime, appears to be 12 Newton per kilogram, well, that's the same as 12 meter per second square. So it's clearly that we don't, the G is not 12 Newton per kilogram because we are not on Neptune. So I won't accept it as right because the way that you have chosen is not correct. Okay. I hope that you understand it. Let's go today. Thank you for attention.